Hello everyone, welcome to today's movie. In today's movie we're going to look at solving probability problems where we have the F distribution, and in this movie we're going to use both Excel and SPSS to solve the same problem. So if we go to Excel first, so what we have is we have a variable called F which follows an F distribution with df1 and df2 degrees of freedom. We are given that the value of f is 4.03. The degrees of freedom are both 9 for df1 and df2. And we wish to know what the probability is of a variable f being equal to or less than 4.03. And therefore, what the probability is that that value of f is equal to or greater than 4.03. So this is our F distribution that you can see on the screen, and I've put there the value of F at 4.03. So this region to the left is the region which is the probability that F is less than or equal to 4.03, and the region to the right, which is shaded slightly all the way to plus infinity, is the region, the probability that F is greater than or less or equal to 4.03. So we want this region first, and then we can calculate this region. Okay, and you'll notice that I've calculated the right-hand region using 3 different methods. And then we'll look at SPSS. So to get this region here, we can use the Excel function called f.dist. And if you look at this Excel function, it says it wants to know x, which is 4.03. It wants to know the degrees of freedom 1, which is 9. Degrees of freedom 2, which is 9, and the fact that we want the actual probability value, so cumulative is equal to true. If you put that in, then this area is 0.975 to 3 decimal places. Now, if you want this region here, you've got one simple method is to realise that the total area under that curve is 1. So if I subtract this area from 1, I get this shaded area here, which is what I want. So this area, the probability that f is equal to or greater than 4.03 is 1 minus that area to give me 0.025 to 3 decimal places. Or I could use the f.dist.rt Excel function, as you can see there. Or I can use the f.dist function. So I've got 3 methods to calculate it. So this area to the right of f equal to 4.03 is 0.025 to 3 decimal places, or 2%, 2.5%. Okay? Right, so what about using SPSS? Well, the solutions are actually there. And just like in previous movies, we want to use the transform function in SPSS. So let's go to SPSS. I've got the solutions there. You can see you get exactly the same. So transform, compute variable. So I'm going to put example 10a. And in this numeric expression, we want the cumulative density function because we want the actual probability for f being equal to or less than 4.03. We may as well do both. Okay, so we want the CDF function and we want f, which is there. So as you can see, it's asking for the numbers. So it wants to know what the variable value is, 4.03. It wants to know the number of degrees of freedom for 1 and the number of degrees of freedom for 2. Okay, and then click OK and just overwrite, and you get the same. You should get the same, exactly the same answer as you did in Excel, 0.975. Yeah. Okay, and then to get the next number, well, you could obviously, if you wanted to do this, you could do this all at once. So I'll just change that to B. But this time, I want 1 minus, and then click OK. Overwrite that value that's already there, and you'll see that the value is 0.0249 or 2.5%. So if I just screenshot that, okay, and then copy that across, that screenshot across to Excel, I'll just copy it straight into there for you. Okay, there we are. So you can see, look, you get exactly the same number values. Okay, so that's the end of today's movie. Bye for